Hi everyone. I'm sorry. I guess my mic was not. I was on mute. But yeah, welcome everyone. This is the first workshop for Build with Celo Hackathon. The build phase has officially started, and build phase officially started. This is the first workshop. We have Viraz here from Good Ghosting. Viraz, would you like to take over and give your introduction?
Yeah, hi everyone. Yeah, good to be here. And so yeah, from I'm Viraz. I'm part of the founding team of Good Ghosting and lead blockchain engineer there. So I'm handling all the smart contract development and backend development there mainly, and been in the space for some time. Been building on Ethereum since some time now, and I've been hacking all my way since a long time. So yeah, good to be here. And yeah, let's get started.
Yeah, sure. Awesome. Great.
Yeah,
Would you
so
be?
today,
Yeah.
sorry, yeah, you were, okay, yeah. I think yeah. So the topic we have today is giving you guys an introduction to Solidity and Remix. So I'll start off with Solidity, right? It is one of the you might have heard of it, or because it is like one of the most like popular languages to write smart contracts. And uh, and uh, just to give you guys a refresher on what a smart contract is, it's a program containing a set of rules which runs on the blockchain to execute transactions. And Solidity is a language is one of the languages that we can use to write a smart contract. And it's pretty much OOP language, object oriented language, and it is like similar to JavaScript. So if you guys have if you guys are familiar with JavaScript at any degree, you will be able to grasp the syntax uh, uh, of Solidity quite easily. So yeah, that's a short intro about Solidity. And then there are some different domains inside it. So I'll be diving into it one by one. And first, we have the compilation of a smart contract, because I feel that is a pretty important part as well. With what happens is when you write a smart contract, right? Uh, and you compile it, the Solidity compiler, for instance, converts that Solidity code into bytecode, which is a set of instructions interpreted by the EVM. And what is EVM? EVM is nothing but the execution layer of Ethereum. So, which is responsible for executing the transactions, and making sure that we have a straight state transition across EVM based blockchains, right? So basically the execution layer of Ethereum. And then the Solidity compiler converts that code, because EVM does not understand Solidity, for instance. So it only understands the bytecode. And when you compile, just know this, that your code gets converted into bytecode. Then we move on to the ABI part of it. When we compile, if you have, like, for example, if you have seen a DApp code or written worked on a DApp as a developer before, so you might know that the term ABI, which is basically a file which describes all the smart contract information, including the interface of the smart contract, which includes all the methods, that you can use to call the public methods and all of that. You can use public and the external methods that you can use to call, used to interact with the smart contract, like from JavaScript, for instance, right? These two components are the ones that I wanted to discuss. So yeah, we can probably move on to the next slide. So yeah, now we'll be diving into Remix. So I'll be sharing my screen, uh, and if you see here, right? Basically, Remix. What is Remix? It's a IDE for an online IDE where you can do quick prototyping to write smart contracts and like do debugging quickly. And like, for example, if you're testing something, or you're hacking on something, and you are short on time, or you want to test something, and so Remix is a good place to just test it out. And yeah, it's basically Remix Ethereum. Or you go on to the you get set yourself a workspace up. So basically, when you come on to remix, you can set a word space up. There's a default word space that you can use, which
Vilas,
remix.
would you like to zoom in a bit so that the participants can see?
Sorry.
Would you like to zoom in a bit so that the people can see what you
Yeah.
are talking about? Yeah.
Is it okay now? Yeah.
Yeah.
So I was saying, yeah. So basically, what happens is when you get onto Remix, Remix gives you a smart contract templates, like already pre-written smart contract templates for you to like just get started with. If you are starting with Remix and Solidity, for instance, for the first time. So if you see when you spin up Remix, it will give you a default workspace which has like these three contracts default by default written for you, like with all the comments and everything, right, to get you started with. And then what we have is, and you can just click on this folder and create a new file, for instance, right? And then yeah, for example, I have like created this instance which is an example workspace. The name of my workspace is example. So I can like just create some Solidity files here and write some code here, right? And just compile and deploy and test, right? So that is that. On the file systems, you can also import your GitHub files in, and also publish your workspaces to GitHub, right? So you have all the import options, or you can import a file from your system directly onto Remix if you want to, prototype quickly. So yeah, and then yeah, then what we have is the compiler, right? And based on, for example, if I have this contract, right, so I can choose to compile this, right? And yeah, basically this is the Solidity compiler with that Remix provides, and it will convert, like I mentioned before, it will convert the Solidity code into bytecode for you to like for EVM to process and the state transitions when you like deploy that smart contract, right? Then you also, here if you see, you get the ABI, you can copy in the ABI, you can copy in the byte code as well, for you, just for you to get, if you want to interact like from JavaScript, or if you need to know the bytecode of the contract for some reason. So yeah, you can do that as well. Then we also, you can like, of course, there's a you can search your files, etc. Then we come to the interesting bit where you can I'll be, of course, be demoing this, but just running through some things. So yeah, you can basically dive into like, there are different ways you can deploy in. So either you can just deploy it to a local VM version of Remix, which is basically just like, for example, like Ganache, where we have a local blockchain, which is not like separate from, which is just local to your system's execution, right? To your system basically. And you can just, if you want to prototype some things which don't really require any external information or any external contracts, so you can just use the Remix VMs, to and so you don't need to like deploy it on a testnet or on mainnet or whatever, right? Or else you can use an injected provider. For example, we have MetaMask, right? So you can connect your MetaMask wallet on any network. uh, uh, because we have like Celo networks are also there, so you can just, if you want to deploy your contract like on a Celo testnet or a mainnet, you can just point to that network and just click on this button, and it will ask, for example, it's asking me now to connect my MetaMask in, right? So that is that. And then yeah, these are two like, you can use like other providers as well, but for like quick prototyping, the most popular ways that popular injection providers are that are used are Remix and MetaMask, right? The Remix VM and MetaMask, and of course there are other options that you can use as well. So then yeah, for example, if I have selected, for example, the VM, because I already compiled my smart contract, so I can just click on this button, and I have my, if you see, it will Remix VM. There's a local transaction that got confirmed, and I can see how I can interact with my smart contract here by just, for example, in the store method, I need to provide an unsigned integer value. So I can provide any value and click on the store button, and this will basically trigger a transaction on the local blockchain that remit spins up. Right. So and then I can, of course, read and all as well. So yeah, that's a small, like a deep dive into remits. I will be like coming on to the hands-on stuff pretty soon. Can we move back to the slides, please? uh,
Yeah, we are back to slides.
yeah, can you move ahead, like go to the next one? Okay, yeah. So then I'll be diving into the data types that Solidity basically uses. Right. So we have integers and unsigned integers. So integers basically, can have negative values, positive values. Unsigned integers can only have positive values. Also, I wanted to point out with EVM, uh, the max size limit of every like data type is 32 bytes or 256 bits. Right. So you if you go beyond that, then the data is basically, because in EVM, you can like read more about it. I'll be sharing some resources at the after the hands-on session, right? But yeah, basically you can read more about it. But basically, how EVM stores data is basically in different like 32 byte slots. So you only have 32 bytes to play with one slot, with one storage slot, for example, right? But I'll be like just giving you a brief on that after the hands-on stuff. So yeah, then we move on to Boolean, which is just takes in 1 byte, right? Then we have strings. Again, it can go up to 32 bytes, and then for one word. And if more than that, then we'll have to expand to the next available slot. And then we have the address that we use. You might have seen on smart contracts. We send out tokens or native tokens to addresses, or check validity, have some rules in the smart contract around who's like triggering the transaction, or who's the admin, or the owner, for example, etc. Right. So it's a 40 character hits string basically, and then yeah, you can transfer tokens, transfer native tokens to it. Then we have enums, which is again, for example, if you are in a like in JavaScript, you have enums, right? Like for example, different uh, for example, if you are developing a smart contract game and there are different stages of the game, so there can be two properties in the enum, that ongoing or completed, if the game's ongoing, or if the game's completed, right? Then yeah, then we have arrays, of course, which is again fixed and dynamic. Again, fixed, we have the same rules apply. It's 32 bytes each element. The maximum limit is 32 bytes each, but you have the options, depending on your use case, whether you want to define a fixed array length or a dynamic array length. Uh, so yeah, now I think we can move on to the hands-on stuff. So we can go to the share we discussed.
Whereas we are not able to see your screen.
define
Would you like to reshare? Yeah. Okay, we got it.
You can, whitelist the, I'll have a constructor with me where I'll just define. We can just go ahead just to give you guys how things work. Uh, yeah. So
Whereas we
msg.sender is
actually
basically
lost you, we lost you from the
sorry.
point where you shared your screen. Like when we moved on to remix, we lost you there. So can you like start from there again? Sorry for that.
Yeah. Am I audible?
Yeah, you're audible.
Okay. Yeah. So I was just saying that yeah. So basically, I'll be diving, showing you guys a simple start off with a simple contract, which we based on the data types we discussed, right? Just to give you guys a context on how, just to give you guys a flavor on how things work, right? And it's pretty straightforward again. But yeah, I'll be just demoing this, and then so the example that I've picked up to start off is a example where an owner can whitelist any address on the EVM on Celo, for example, right? To do any operation, right? Like, and we'll get down what that operation would be, but to start off, it's just a simple contract where I can whitelist any address to perform a certain operation, right? So to start off, and I'm not going to use any external contract. So I'm just going to do everything locally in Solidity, right? So I have defined an owner which I'm defining in this constructor, which gets triggered when you deploy the operation. So I'll have a mapping, where whether an address has been uh, uh, whitelisted or not. Again, mapping is another a data structure sort of a thing. It's just a key value data structure in Solidity where you can have like multiple keys as well. And only, of course, there only can be a single value depending on if you're using a nested key or not. And then we can use nested mappings as well. It's basically consider it as a JSON object which has a key and a value. So in this case, the key is the variable. So this basically is just going to give me whether address has been whitelisted or not, right? So I'll just define a method to, let's say, whitelist right. So each function that you create in Solidity, right, it gives you that right. If, for example, I had named, instead used public, which means that it can be called inside the contract and outside the contract, right? And then we have internal, which basically means that the function can only be called from inside the contract. And private, we can also have private, like for example, if you're working with inheritance, right? Sorry for that. Yeah. So basically, private means that the extending class won't be able to call this private method. Only the example contract can call. The extending contract won't be able to call, right? So, but for this use case, I'm just going to use external, right? And then what I'm going to do is I'm also going to use custom errors. Uh, so with Solidity, right, with the new versions, there we can have in Solidity we can have like rules like I mentioned before, right, where we define whether if certain conditions are met, then only this transaction can be executed, right? And to enforce those rules, we need to have some checks in the contract code where we revert a transaction if a certain rule is not met, right? And to do that, we have a concept called custom errors, which was introduced in the later versions of Solidity, which basically helps you define those revert points in your smart contract, right? So now in this for this example, I'm just going to define a custom error which is going to be not owner. Right now, what I'm gonna do is I am gonna check here with the if statement that if, and I'm also gonna first define an address that I'll be whitelisting, right? So I'm just gonna define it here that this is the address I'll be whitelisting. Now I'm gonna check, right, if the sender of this transaction to whitelist the user is not the owner, then we're gonna revert the transaction, right? So we are going to revert this, and with a message, a revert message, which is going to be not owner. And if not, if it's the owner that is triggering the transaction, then we'll just initialize the mapping for that particular address, right? And it's going to be true. Also, another thing I wanted to mention is by default, for example, if I hadn't initialized owner here, the owner value would be the a burn address, which would be basically be address zero, right? It's just a burn address where you can send tokens and burn them off, right? If you want to, like, for example, transfer a ERC20 token or a NFT, and you want to burn that, right? So you, what you can do is you just transfer this, and that's what the ERC20 or the ERC721 interface does, the contract does, right? They transfer those assets to this address, which is just a zero address. And by default, the mapping values are also, for example, here boolean, it would be false, right? For example, yeah, if I hadn't initialized it, so I need to initialize it, right, to make it true. And same goes for the for the variable types as well. If by default I won't be, if I hadn't used public here, so this variable is by default private, right? So I need to use a public uh, keyword here to identify that this variable can be read from the from outside. So yeah, now I'm going to compile this, right? And we see the contract has been compiled. We just got a license warning, so we can ignore this. And now what I'm going to do is I'm going to deploy this to a local local version of the EVM, right? Local remits version that I mentioned, right? And as you see, we have a transaction, we have those details in, uh, right? We have the hash, we have the from address, which is the owner in this case. And now I'm gonna dive into how we can whitelist an address. So now what I'm gonna do is I'm gonna copy a address here, right? For example, I'll copy this one, and I'll mention this in the to whitelist this address, right? And as you see, our transaction got confirmed. So now I'm going to check if this address that I whitelisted has been whitelisted or not. And I get true, so it has been whitelisted, and I can also read in the owner, right? Now what I will do is I'll show you another thing which is a bit more advanced, but I want to show this. You know, so we, if you see this, we have an option here to debug the transaction that we just did, right? And I'm going to debug this value, right? Just give me a second. Yeah, so I'm going to debug this transaction. Yeah, so this is the transaction that we had. And now if you see, we are in the debugging console of remits, where we can see what is happening exactly in, inside the EVM. I'm not going to dive deep into this. It is basically, once you get drafts of how things work, like internally inside the EVM, we can, you'll get more idea about how these operations work. Basically, this is just, the set of instructions that I mentioned before that get converted from the Solidity code into bytecode, right? So these are just those instructions which EVM executes in order to when you do any, like, if you want to read from the blockchain, or if you want to write to the blockchain. Like for example, when we called the whitelist method, we were writing onto the blockchain, right? And then you can just step over like we do in JavaScript. For example, if you debug some code, you have those debuggers, right? And this is similar to that, and you can just debug and step over how's the operation happening. And with EVM, it works with a stack, right? So, but yeah, I'm not going to dive much into this. You can like I'll be just letting you guys know some resources which you guys can use to get good graphs on EVM and how things work internally, how transactions get confirmed and all of that. So now we'll continue on to the other example bit. uh, yeah, because yeah, that's the topic on hand. So yeah, this was this, right? Now I'll be just demoing something around arrays and structures, right? So yeah, we can just consider another maybe I'll just consider another example instead, right? So I'll write in another file in, and then uh, let's say example one, right? So we'll define the version again, and yeah, always use the latest versions of Solidity, right? Because there are a lot of things deprecated if you use a older version. So better to use test everything and write contracts with the latest version, right? uh, so just name it as new example. Now, yeah, I mentioned to you about you guys about the arrays, right? About arrays, how arrays work in. So, yeah, basically, we can. I'll just be showing you this. Uh, yeah, so there can be two types of arrays, right? One is a dynamic array, where, for example, you know, uh, I can name it as, for example, if you want to write some student scores onto the blockchain, right? So yeah, I can define a dynamic array, which means the size it's not fixed, of course. And then we can have a function here, right? Set scores. And for example, I can use a unsigned integer with the maximum uh, size, right? And I can name it as store, and I can name this as external again. And then what I can do is simply just do this. I can use a push operator, a push function, to just push the uh, you know uh, the store to this dynamic array, right? And now if we compile this, uh, and if we deploy this, right? So we have our contract deployed. Now what I'll do is I'll just enter any store in, and we should be able to read this. Right now, what I need to do is I need to pass in the index of the array. And because with arrays, you might know the indexing starts from 0. So you'll just read the first element in the array, and that is 4. So this is a dynamic array, and we can push any number of variables into the array, right? So, and then what we can do is we can also do this, where we can have a get stores, but we can use a just to show it this, we can use uh, static array, right? A fixed array, and just return the variables that way, right? So what we can do is we can use. And also another thing I wanted to mention is, for example, if you want a method that's not writing to the blockchain, but that's just reading to the blockchain, then you can just use keywords like view or pure. Pure is basically used when you are not interacting with any storage stuff, storage, memory part of the contract at all. So then you can use pure. Or if you are using, for example, if I want to read, since student scores is part of the storage, and I want to read from the storage, so I'll instead use view, right? And what I can do is, for example, I mean, in this case, I can use pure because I'm going to use a fixed array, right? So which is going to be like this. I'm going to define the size here, and just name it, for example, my store. And then I can just do my store 0, the first element, right? I can just assign, like, for example, 45, right? And then what I can do is I can just return the array, right? And also with arrays, or for example, if you're returning a string or a structure, which I'm going to come to next, you will have to use the keyword memory, because they by default won't, you have to specify that they exist in memory, right? Because by default, uh, yeah, you they're not. So you need to, while returning, you have to specify the return type. If you're, for example, returning a string or bytes, right? Or or you're returning, for example, a structure, object of the structure, or if you're returning an array, so you need to identify, you need to mention this, right? Now what I'm going to do is I'm going to just compile this again. So there's I will just dive into what happened. Oh, okay. Sorry. Yeah, I by mistakenly I returned this. So I'm gonna. Uh, sorry, just I. Oh, sorry. Yeah, I forgot to mention. You have to mention the memory keyword here as well. So by default, it's not. You need to mention it. If you're defining something in memory, and what the memory keyword means, that the my score array, for example, will only remain in scope, like active during the scope of this function get stores. Right? It's not going to be active outside of it. It's not going to be persistent, basically, right? So you can't access my score, for example, from external contract, from externally, like from an external contract or from JavaScript, right? Whatever. You'll need to call this method get scores and then return the method. Now we're going to deploy, right? We're going to deploy this again. I'll just remove the recent version. So we're going to deploy this again, and we got this. And now what we're going to do is we're going to return the array. And as you see, we got a array defined by default. We got our elements, 45 and 0, because we defined two elements here. And we only, by default, the element values are 0, and we only initialized one element, like we only updated one, the first index. So yeah, that's the bit on dynamic and static arrays. Now I'm going to dive, finally dive into the structures, right? Which is again a pretty important bit if you're going with Solidity, right? With Solidity, I mean, with smart contracts per se. So yeah, I'm going to spin up another contract quickly. In fact, copy this just to speed up. Yeah. So we have. Right, and yeah, so now what we, for example, now we need a student's, some of the students' details in like four or five, 3 or 4 details, for example, for a student, right? So the way we can you do that is not, and we don't want to, have those multiple variables, and there can be any number of students, right? So what we can do is we can use a struct keyword, right, which is basically where you can just store all of the information for a particular address. For example, in this case, I'll just dive into that. So you can just store all that information together in terms of the storage space in the EVM, right? In the contract, basically, right? So what we can do is, for example, we have a student's grade point, right? And uh, I'm using only 128 bits, if you see, right? Then we have, for example, students. We can maybe use a maybe we have some sort of a credit score mechanism in our application, right? Based on the student's performance, or something like study to earn or something, if you're trying to build a system like that, right? So what we can do is we can have a mapping here which will point from the address to the student, right? To the student strut. So basically the value here would be a student strut, right? And not a like a default like other like native native data types in Solidity, right? It's a custom data type, it's a strut, right? And what you can do is we can define, name it as student info, right? And then what we can do is now, yeah, for example, now I can just we can have a simple method, to set student details, right? And then I can specify the address of the student, their grade point, right? And then get grade score. Sorry, name it as external, define it as external, right? Yeah. So now what we can do is we can define an instance first of the strut and initialize that instance of the strut with values, and we can define it as a memory because we only need it. It anyways, it's we are going to save it in storage with the mapping, so we can use the memory keyword here, right? Because also another thing to point out is the memory keyword is cheaper if you using things in memory, like if you're loading stuff in memory or you're writing in memory, uh, which is the non-persistent part of storage, right? So that is more cheaper than if you're writing to storage for obvious reasons, because we all know, we need to spend gas in to execute any smart contract transaction, and the more optimized your smart contract is, the more cheaper it would be, and using memory depending on the use case will make the transactions cheaper, right? So yeah, we have a student object here, and now what I'll do is I'll just define the initialize the strut with the values that we passed into the method, right? We have grade point and we have grade store, right? And now what we can do is we'll just simply you know define it. I'm not for demo purposes, I'm not having any like input checks here, but we'll all obviously, you'll need to have input checks wherever necessary, like I showed you the custom error bit, right? So that part is obviously very very important, right? This is just to, for demo purposes on how struts work. And yeah, so we defined a strut instance into memory. Now what we can do is we can just set it in the mapping, and we should be done, right? And then uh, what we will do is we'll just compile this again, just checking. Okay, there was, okay, I left it, sorry, my bad. Yeah, yeah, so it's compiled in. Now I'm going to deploy it again. I'm going to remove the other instances. In fact, we can just use this. So yeah, it's deployed to the local VM version of remits. And now what we will do is we're going to pass in the values in, right? And for passing values inside, we're just going to be using simple, uh, you know uh, we'll just separate them by comma, right? And then define, so this is my address that I want the student to be, and then this is the grading point, for example, out of 10, and this should be this is the grade score, right? So I've defined the methods here, and then what I'll do is we have our transaction confirmed on the blockchain. Now what I can do is I can just specify my address for the student I want to read the data, and I should be able to get the grade point and the grade score like you see here, right? So yeah, I think that on just giving you guys a demo on everything. One thing, sorry, I forgot to mention one thing, which is again a very important bit. If you see here, I only used unsigned integer, and I defined 120, the maximum size, to be as 128 bits, right, and not 256 bits, which is the maximum. Now what happens is when and this is a very important bit when you're writing smart contracts, especially if you get that initial drafts. If you're able to grasp things initially, you get some practice in, you get that confidence in you after writing a good decent amount of smart contracts, like participating in hackathons and stuff, right? So what you can do is you then important bit that comes into the scenario is comes into the consideration is one is security, of course, but the second thing is gas optimizations, right? And what happens with EVM, like I said, we have to play around with that 256 bit figure, right? So in this case, for example, I could have just used unsigned integer 256, like u in 256 on both for both the variables. But what would that mean? That I would be using two storage slots, right? Because I'm using the maximum storage slots for both of them, right? But instead, what I did was I knew that, for example, with u into 128, right? The maximum value, for example, credit score will be able to have would be 2 raised to the power 128 minus 1, right, which is a big value, right? So I am sure, as a smart contract developer, that this value is not going to exceed this number, right? So what I did was I defined the maximum limit to be unsigned integer u into 128 instead, right, which means that I am only, instead of using two slots of storage, I'm using one slot, and I'm saving gas, uh, you know because because of this, right? So these are some like good important things to keep in mind, while I mean, this is a bit more like when you start off initially, you get a good hands on on how Solidity and smart contract work, how you know you write contracts in Solidity and how smart contracts work. So after you get that bit of insight, then you can start diving slowly into these things. And do have some resources uh, that I would like to share. I think one is pretty much is this, right? evm.codes, which is a very again, this is not really related to like writing basic level smart contracts, but this is more sort of to get you an insight on how things work internally when a transaction gets confirmed onto the blockchain, or how that process works, that state transition works. So you can like read more about it from this website, which gives you a detailed instructions about each instruction that the EVM uses to do state transitions and all. And also, I also did a recent presentation recently at a Web3 conference, which I'll be sharing. I'll be sharing the link in the comments, so which you can go through to see different like good resources around security, around gas optimizations, etc. So yeah, I guess on the hands-on part, I think we should be done, and I think we can take Q&A, Harpal. I think, yeah, unless it is something. Yep.
Yeah, sure. So first of all, awesome stuff. We got to learn a lot. We went from through some basics of data types, and then we went to deep dive into Remix. We got to know about the debugger, and finally we even got to learn about custom errors. So there was a lot of things packed in this workshop, and yeah, definitely we are up for Q&A now. So if anyone from the audience has any questions, uh, we are ready to take them. By the time we get any questions, like I have a question if you are willing to take one, Viras.
Yep. Yep. Of course.
Yeah, like I've seen that we don't use floating numbers a lot in Solidity. What are your views on that? What could be the potential reasons for that?
Yeah, I mean, it's not right straightforward, right? Right now, one sort of a pain point is that Solidity right now does not really. You'll have to, I mean, use. There are libraries. For example, there's a library called PRB Math, right, where you can use use floating points. Like internally, they have that library has a code which you can use to sort of user adjusted method of floating point variables. But yeah, that is a pain point. Like by default there are no floating point variables in Solidity, so you have to handle floating point calculations in your code. So one thing that you can do is there's a muldiv, there's a thing called muldiv. I can just
Okay.
probably share my screen. Just give me a sec.
Yeah, sure.
Yeah, so there are things like muldiv. Basically what that means is yes, I'm just sharing my screen in, right. So basically this means that you can, first, if you are like you expect uh, you know uh, floating point numbers in your smart contract, then what you can do is, because Solidity will not be supporting that, so what you can do is you can multiply. For example, if you're doing a divide operation, right, and that's
Right.
where floating points come in. So you can multiply your numerator by a constant, and then divide it by, then do the division, and then at a later point you can divide that number, the result that you got, with the constant that you multiplied it with, depending on your use case, right. So there are libraries which help you do that. Again, by default, floating points are not available. You'll have to, the maximum decimal points are 18, right. So you'll
Correct.
have to, if it goes beyond 18, so you'll need to handle it on your end, like either use a library which handles this for you, or you can, like, just multiply the numerator by a constant and then do the division, and then later do the division by the constant again to just cancel out that, right, depending on the use case, right, what are you trying to
Right.
achieve. And these
Yeah.
libraries help with that.
So like for an example, we can take like if you want to do let's say 99%, then what we can do is we can multiply with 990 and divide it by 1,000, or we can go even more higher
Yeah, you can,
to
yeah, do
achieve it.
multiplication, for example, with 1,000, and then you can divide with whatever
Right.
number that you're trying to. Yeah. So yeah, you can do it by that. I mean, it's not right now. We don't have a straightforward way. This is the only way to do it. But yeah, this is. I mean, that's the best. We can make of right now. In future, I'm not sure if there would be a way, by default, that we'll have those floating points. But right now we don't have. And yeah, that's a good question. Uh,
Right. Great. Looking for some questions from the
Also,
audience.
should I share the link somewhere? Can I share this presentation link just for this has some good like resources?
Yeah, sure.
I
If you
can.
can, yeah,
I'll just share it in the private chat. I don't have access to the comments. Like I cannot comment.
yeah,
I'm logged in, so I'll just mention this here. This is just some EVM and security resources in.
sure.
If people want to dive deep into this.
Just send it on YouTube to the audience. And other than that, for the audience, if they don't have any questions, this stream is recorded. So in case you want to go through it again, it will be available. There is no harm in rewatching this. We also have more events planned. So if you are willing to learn more, you can subscribe to the community calendar. Link to it is here. You can go to celo.org/community. You will be able to see a calendar there. You can add it to your calendar, and then you'll be able to get notified for all the events coming up. And if you are not aware about the hackathon, please go ahead and visit this link. And the hackathon is already, the phase one is already up. Phase one is ideation. So just submit your ideas. You have until the end of this week. So yeah, go ahead and submit your ideas. And all you have to do right now is just submit an ideas. But we have started the build phase as well. So if you have got an email from the team that your idea has been approved, then you should start building. And yeah, looking out for any more questions.
Yeah, just wanted to also mention that if any you guys have any, like if you watch the YouTube video and if you have any doubts, like any queries or anything, I'm reachable on Twitter Viraz04, so you can hit me up for any like queries or anything regarding your
Definitely.
hack or whatever. Yep, yep.
Definitely. And we also have our own Build with Celo Hackathon Discord. So Viraz will be present there as well in case you want, if you have any queries, you want help with anything, Viraz will be available there in that Discord. We also have weekly Discord events in the Celo Discord and also in the Build with Celo Hackathon Discord every Tuesday and Thursday, and we will be helping you guys out there as well. So lots of resources available for help. So yeah, I think we don't have any questions from the audience here. So maybe we can end this session here. Um, so yeah, thank you Viraz for coming in, taking out your time and doing this session for us. Yeah,
No
looking
worries. My
forward.
pleasure.
Great, awesome. Thank you everyone who joined us. And if you need any help, the links are present here. Reach out to us. Hackathon page is on Hacker Earth. We have two Discord servers as well. And yeah, jump in and reach out to the team. We were very happy to help. Thank you everyone. Thank you,
Thanks.
Viras.
Thanks.